Okay, so we have covered the standard form. Z equal to A plus BJ standard form. And then this can be expressed into coordinate ataupun Argand diagram. Okay, so into Argand diagram Y and X, where from the Argand diagram we can know the value of R, which is square root of A squared plus B squared, and we can know the theta, the argument. This is modulus, this is argument. Okay, theta equal to arctangent of B over A. Okay, so this is argument Z, this is modulus Z. Alright, so that is the first few things that we learned in the previous slide. Okay, next, proceed to the next slide. Okay, we will look at another two form of complex number. Okay, where beside the standard form and we draw it into the Argand diagram, we also can transform the standard form into polar form and the exponential form. Okay. Alright, what is polar form? Polar form is changing the way you write the standard form, okay, into trigonometry function. Okay, into trigonometry function where you need to A and B, okay, you need to express it in trigo function. Okay, so in order to do that, I have explained to you before, okay, on how we got the function, okay, the trigonometry function. Okay, when we plot into the Argand diagram, we will have the theta, and we get the r. Okay, so where a is the distance from the origin to the x, okay, to the value at the x-axis, and b here is from the origin to the value of b here, which is the imaginary. Okay, so this is the a value and this is b value, and then we will apply the trigonometry identities where to find the cos theta. The cos of this theta, cos is adjacent, which is a, okay, over the hypotenuse, which is the r. Okay, so this is one equation. Okay, sine theta, okay, sine of this theta is the opposite to the adjacent. So this is equivalent to b over r. Okay, and what is tangent? Tangent theta is the opposite over adjacent. Okay, this is second, this is third. From first, okay, remember we want to change, okay, substitute the to substitute a and b here to trigo function, right? So we from equation here, what we need is a. We want to know what is a. So a here, if we rearrange, this is equivalent to r cos theta. From 2, we want to know b, okay? Our unknown is b, okay, the imaginary part. What is b? We rearrange this. This is equivalent to r, okay, r to the left hand side, okay, sine theta. Okay, and as usual, the theta is arctangent of BA. Okay, so now we can express our z into polar form. Okay, so z is equivalent. What is a? What is a here? A is this. Okay, r cos theta. And what is b there? Plus b is r sine theta. Don't forget your j here. Okay, so to avoid confusion letter, so I put J to the front of the trigger function. Okay, then we factorize R. Okay, we get cos theta plus J sine theta. Alright, so this is called polar form. Polar form is trigonometry function. Okay, so the whole thing here is called polar form. From standard form to polar form. You see, it is really related to this. Okay, you just need to master this part. Okay, so A is r cos theta, B is equal to r sin theta. If you can understand this figure, you don't even have to remember the formula. Okay, you can generate it at any time. You can derive this at any time you want. Okay, you don't have to remember. Okay, you just need to understand the concept, and yeah, you are free to go. Okay. Okay, so I have explained whatever the equation in this slide. Okay, in the first slide. Alright, so nothing difficult about polar form. Whenever you can understand from the first where you write the standard form. Okay, so polar form is just substituting A into the trigonometry function. Same goes to B. Okay, so sine is always your imaginary part, and cos will be always your real part. Okay, so all the equation here we call it polar form. Alright, so remember this. Alright, so this is how we write the coordinate for the polar form. Alright, because for polar form, we always, wherever it is, if the first quadrant, we will have theta and we have r. So this is how you write the coordinate for polar form. Even if it is in the second quadrant, you still have the theta, where theta is always considered from the x-axis. So this is your r. Alright, if it is in the third quadrant, okay, see, you always will have your theta here, and this is your r. Okay, and if it is in the fourth quadrant, okay, it's always theta will be considered from based from the x-axis, and the length or the radius is r. Okay. Okay, as an exercise, let us look at example A and C, and I will leave B for you to try. Okay. Alright, so here we need to represent the following complex number in a polar form. Okay, so when you see the word polar, remember trigo. Okay, so Z for A, Z equal to minus 3 plus 4i. Here you know that your A is minus 3, your B is 4. Okay. And we have proved just now that complex number, the standard form can be expressed in polar form by using the formula R equal to cos theta plus J sine theta. So this is what we need to fill in. We need the R, we need the theta. So where do we get the R? We can get from substituting A and B into the formula R equal to square root of negative 3 squared plus 4 squared. So 16 plus 9, it is square root of 25. That gives you r equal to 5. Okay, and then now we have the r. Okay, what else do we need? We need theta. So what is theta? Theta is a tangent of b over a. B is this. Okay, you can directly substitute into the form into the calculator. Okay, that will give you negative 53.13 degree. Okay, please be careful. Make sure it is set to be degree. Okay, in the calculator, so you get degree answer. Okay, and to know the location of negative 53.13, okay, draw the Argand diagram, okay, and plot. Where is the 4? 4 is here. Sorry, it is negative 3 because A. Negative 3. Sorry. This. Okay. So negative 3 is here. And 4 for y is up here. Okay, so this is roughly the location of z. Okay, so when we connect from the origin 0 0, this is our r, which is 5. Okay, so the distance here is r equal to 5, and the theta is always from the y-axis, x-axis. Okay, so it is negative because tangent in the second quadrant is negative. Okay, so it is proven here because it is in the second quadrant. That's why tangent give you negative value. So this is negative 53.13 degree. Okay, so the small angle here, which is negative, okay, is based from the x-axis count to the line here. So it is following the clockwise. When follow the clockwise, it is negative. Okay, but we don't want negative angle to be filled in into our theta. So what we can do is, okay, please consider the angle from the 0 axis, okay, from the x following the anti-clockwise. Okay, so here to here, how to get the angle here, the theta here? This is equivalent to 180 degree minus V 53.13 degree, and you get 126.87 degree. So this is the angle or the theta that you should fill in to write into polar form. So R is 5. So it is cos 126.87 degree. Okay, plus with J 126. Sorry, sine 126.87 degree. So this is the polar form of the question A. Okay, so next let us look at C. Okay, same thing here. From here, A is 0, B is negative 5 because we only have the imaginary part, remember? Alright, so to express in polar form, we need R and we need the theta. Okay, so follow the same step. R is equal to square root of 0 minus 5 square. That also give you R equal to 5. Okay, and theta is a tangent of negative 5 over 0. So this is the same case as we did in the previous slide. Alright, so this is undefined case. So let us look at the location of the z. So it is negative 5. it is 0 and negative 5. Okay. Okay, so where is negative 5? Negative 5 is here. Alright, so I change the color. Okay, where is it? We connect from the origin to the point. Okay, so this is where your theta is. Okay, so from here it is obviously theta is 270 degree. Okay, so you can write the answer. Okay, z is equal to 5 cos 270 plus j sin 270. Or if you look at the answer here, okay, they use 90 degree. Okay, you can use 90 degree, but you must be careful. Okay, where is 90 degree? Where is the 90 degree in this answer? 90 degree is here. Okay, it is considered from the x-axis, but following the clockwise. So when it follow the clockwise, it is negative 90 degree. Okay, so negative 90 degree, since it is negative 90 degree, when you substitute into here, cos 19 degree, okay, cos for this, okay, in the fourth quadrant, because it is in the fourth quadrant here, okay, remember, this is quadrant for cos, the value is positive, that's why you just write 90 degree here. It won't become negative in the fourth quadrant for cos. Okay, that's why we drop negative here. But for sine, okay, it will become negative. Okay, so but here, for sine, it is negative because sine will be positive here in the second quadrant. When sine is in the fourth quadrant, it is negative. That's why it is negative sine 90 degree. So this is how the answer become cos 90 degree minus I sine 90 degree. Okay, we don't put the sign negative sign in the negative 90 here. Okay, because when we tekan negative 90 pun, we will get negative value. So to be nice, we just put it in the front here. Okay, negative in the front here. So dapat macam ni. So you have two way to write it. Alright, if you are not confident of writing this, okay, writing by using this, just stick to this answer. Alright. If you want to change into negative, you really need to master the concept. Okay, if not, you can easily make a mistake there. Okay. Okay, same case for B here. Okay, when you try, okay, you should get a large angle. Okay, large value of angle here. Okay, same to this case. It is quite large angle here, which is greater than 270. That's why it changed to 90 degree. Okay, so same case apply here. Okay, they use the angle that is following the clockwise. Okay, that's why it changed to negative here, and the angle that you get is just a small angle. Okay. Okay, so next example. Okay. If we can transform, okay, express standard form to polar form, okay, we also can reverse the process by transforming the polar form back into the standard form. Okay, so hold to the formula of, remember this one, A equal to R cos theta, B equal to R sin theta, and we have theta is equal to arctangent of B over B, and R we have square root of A squared plus B squared. Okay, so now, okay, we have the R, we have the cos theta here, and we have the I sin theta here. Alright, so what we can get from this is R equal to 2, theta equal to 210. Alright, so from here we can directly get the value of A, where A is 2 cos 210. Okay, B is equal to 2 sin 210. Okay, when you substitute the value into the calculator, you will get this is equivalent 1.7 something. Okay, and B here you will get negative 1. Okay, so substitute back into standard form A plus Bj, you will get negative 1.7 minus with 1g. Okay, okay, in this case, okay, it's stick to the value of square root of negative 3. So where do we get negative 3 here? This is because the person who solved this, they use a spatial angle. Okay, spatial angle. If you want to know, I'll let you know. Okay, there are two spatial angle where the triangle has 45 degree and 45 degree. This is easier because each of these side is one, the radius is 1 and this is square root of 2. There another one triangle which is 60 degree, 30 degree. So 30 degree, this is 1. Okay, this is square root of 3. This is 2. Alright, so when you go back to this, okay, this is when A is equal to 2 cos 210. Okay, this is actually equivalent to 2 cos 180 plus 30 degree. Okay, 180 plus 30 degree in the quadrant. Okay, it is here. Okay, this is 180 part. This is 30 degree part. Okay, so this is where they apply this triangle. Okay, so if we connect this to make sure it become like this, this is where 1 is. There is square root of 3 and here is 2. So cos in the third quadrant, remember the location of this z is in the third quadrant. So for third quadrant, cos is negative. Okay, so remember it is negative. So cos, what is cos of 30? Cos is adjacent, which is square root of 3 over the hypotenuse 2. Okay, so this is cos 210. Okay, alright, so when we substitute in here, this is 2 times with negative square root of 3 over 2. So cancel 2 with 2. This is where we get negative square root of 3. But don't worry, whether you use negative square root of 3 or negative 1.7, they are equal. No worry, you can leave your answer at any form you like. Okay, if you remember these two rules, okay, spatial triangle rules, then you can apply this look nicer than the decimal place of answer. Okay, that's it. Okay, so this means that for B and C, they also use the spatial angle lah, because the angle that the figure that they use look nicer and neat. Okay, if you are not confident, just use the calculator and get the answer directly from there. But please be careful with the plus minus sign. Okay, but if you want to get more explanation on how to use the spatial angle, okay, you can request it separately. All right, I will explain more. Okay, so I just leave the rest of the example for you to try. Okay, in this slide, it explains on the operation that involve with polar form. Right, so if you have two polar form, okay, in this form you have 2z in polar form. Okay, when you multiply both complex number, the complex number in polar form, okay, it is equivalent to the first r you multiply with the r. Okay, but for the trigonometry, how you deal it is you just add the angle. Okay, so cos and sine won't become square. All right, so let's say z1 is r1 cos theta 1 plus j sine theta 1, and you have another polar form labeled as z2 r2 cos theta 2 plus j sine theta 2. Okay, when you multiply these two, okay, z1 multiply with z2, okay, it means that you multiply the r1 times r2. Okay, while for the cos, it won't follow the regular operation for multiplication. Okay, this involved with the trigonometric identities as well, where when you multiply the two different angle, you will get cos theta 1, you will plus with theta 2 plus with j. Okay, sine will become sine theta 1 plus sine theta 2. That's it. Okay, so you just apply. While for division, z1 divided by z2, okay, r will be divided by, as usual, okay, it will follow the operation. But for the trigonometry part, you will deduct the angle for division. Okay, so theta 1 minus theta 2 plus j sine theta 1 minus theta 2. Okay, so just apply the formula. Okay, let us do one example for this. Oh, where is the answer for B? Alright, I think this is the answer for B. B, run to there. Okay, so let us do A. Okay, first we do the multiplication. Alright, so multiplication said if you have two polar form, you multiply them, means you multiply the angle. sorry, the r. So 4 times 5 is 20. But for the angle, you will add them. So you will get cos 175 degree plus with I sine 175 degree. So you just substitute into your calculator. You will get minus 19.924 plus 17431 I or G, depend to what you choose to use. Okay, so 175 in the Argand diagram, it is in the second quadrant. Okay, so cos in the second quadrant. Okay, this is second quadrant. What is the value of cos in here? It is negative, right? So that's why you get negative here. You will get negative automatically when you substitute into the calculator. Okay, but this is just to get to give you the idea. I keep on repeating it so that you remember. Okay, only sign will be positive in the second quadrant. Okay, that's why for sine 175 here it is positive. Okay, look at positive. All right, so here. Okay, for division, okay, if you divide z1 by z2, so you will divide the value of r. So it is 4 over 5. Okay, so for division, you will subtract the angle. So cos negative 25 degree plus I sine negative 25 degree. Okay, so to make it easy, you just substitute into the calculator and you will get this answer. Okay, but let us look at the sign only. Check on the sign. Okay, check on the sign. Where is negative 25 in the Argand diagram? So negative mean it follow the clockwise. Okay, so from the x-axis it follow the x-axis. So negative 25 is this. It follow the clockwise and it is a very small angle here. Negative 25. So what quadrant it is? It is the fourth quadrant. Let us look at cos. Cos of this, it will be positive. So that's why it is positive here, the answer. But it is negative for sine because only cos is positive here in the fourth quadrant. Whenever it involves sine here, it should be negative. So that's why it is negative here. Okay, this is how you check the answer lah. Alright, but if you just substitute the value into the formula, you will get the positive and negative sign straight away. Okay, so you just tulis sajalah into sebagai jawapan. Okay, but it is sometimes good to understand from the basic. Okay, so when people ask you, you know how to answer it. Okay, the reason behind the positive and negative sign value there. Alright, so I leave B for you to do it. Okay, hopefully you can get the similar answer. But if you look at here, okay, the person who answered this question, he did use the spatial angle. Okay, because the answer is 3 the square root of 2 and so on. Okay, usually that kind of figure we get from the spatial angle lah, okay, of the triangle, right?